today I am talking about visualizations using SVG, Canvas, and WebGL, mostly in Vue, but with also a lot of agnostic examples that can be used in any framework. First, to introduce myself for those who don't know me yet. Maybe you weren't here on the first day. I'm Chris, and I'm in the Vue core team, and I'm a consultant in my day job. That's how I actually make money. And I was a specifically data visualization consultant for a long time. There was a year where every startup wanted a super fancy animated dashboard with cool charts and stuff. And that was a good year for me. That was relatively early in my career. And I thought wow, I've got things figured out. And then the dashboards became less popular. And then I had a harder time for a while. But I still really, really love data visualization, still use it a lot. And this is me right here. I'm this one. Super excited about dinosaurs. Before I built code, I built dinosaurs. And I was really, really excited about it. And this is still how excited I am about code and Vue and data visualizations and these technologies that I'm going to talk to you about today. Really looking forward to showing you all this cool stuff. On the Vue core team, my official title is the good word putter together. Write a lot of docs and also work on other tooling to make people's lives easier. So my goals for this presentation are, first of all, exposure. Expose you to the different kinds of technologies that you can use for visualizations in the web, and also get you to have an idea of what that code might look like and help you feel a little bit more comfortable maybe writing it yourself. Why you would use each of these tools over HTML, each of these technologies, and what the trade-offs are. Some tips and tools, tips generally that you can use for data visualizations and especially for high performance data visualizations. And also tools that you can use alongside these technologies to make working with them easier. And also take a lot of the harder parts out and let other libraries do them for you. I'd also like to be agnostic-ish. So even though a lot of these examples are in Vue, all of them translate very well to any kind of component-based system, actually. And a lot of the examples don't have anything to do with Vue at all. And one other thing that I want to share is that I will be sharing these slides at the end. So any of the examples that I go through, you will see some code and there will be live code examples. You'll be able to play with them afterwards on the slides if you'd like. So now, why not just HTML? What's wrong with just using HTML? It's great for boxes and text. And you can fill in those boxes and make rectangles with CSS. And if you add a border radius 50%, you can even turn that into a circle. And if you click on any of these examples in my slides, by the way, it opens in CodePen so that you can play around and try to tweak these examples yourself. So the three technologies I'm talking about today, SVG, Canvas, and WebGL, are actually alternatives to HTML that you can use within your HTML files. SVG, standing for Scalable Vector Graphics, looks a little bit like HTML. It's still XML based. You still have a starting tag, closing tag, and then you still have attributes that you give values. That should look pretty familiar if you're familiar with HTML. And this is how we'd make that same gray rectangle with SVG. And you'll notice I'm providing not only a width and a height, but also an X and a Y. Whenever you create an SVG, you're basically creating a sheet of paper that you can draw on. And everything inside of the SVG is what's actually being drawn. So we're saying we want this shape, this rectangle, to be 10 pixels from the left, X, and 20 pixels down, Y, because SVG uses a coordinate system that starts from the upper left-hand corner. Styling SVG elements will also look a little bit familiar and also a little bit unfamiliar. You can see here with these with these CSS properties, these aren't the properties that you're probably used to. We use fill orange to give this circle an orange background, and we use stroke and stroke width for what we would normally think of as the border. So even though you can use CSS to style any SVG, a lot of the properties to actually change how they look are often a little bit different. And what's nice is you can use SVG just like HTML. So this here is an example with Vue. We have an SVG here where we're drawing a rectangle inside, and we have these sliders where we can actually change the X and Y coordinates, and also the width, and the height. And for people who are looking closely, you may also see that the slider for Y is changing as the height changes. Because depending on what the height is, you can only go so far and stay within the SVG. So the way that we're doing that is by binding, whenever you see this colon attribute and then some value, we're actually binding data in our Vue app to these attributes so that whenever that data changes, these attributes will automatically update. We're defining some data that changes here, and then also based on that data, defining some computed or derived properties like the max X, the max Y, the max width, the max height, to make sure that we always stay within the bounds of the SVG, the bounds of our painting area, essentially. And that works just as well as it does with HTML. Anything, no matter what framework you're using, if you can do it with HTML, you can do it with SVG. Now, what's nice about SVG is it's not only squares and circles. You can also create a lot of different shapes that would either be impossible or incredibly hacky in HTML. And before I knew SVG, I actually did some really hacky stuff like this sometime to try to make a zigzag where I have a rect or a div that is transformed and then turned a little bit. And then I have another one that's white that actually takes off part of it so that I get a little point, and all this hacky stuff, and actually ship that to production, and it works okay, but I definitely wouldn't recommend it. Just move a little bit. Here we go. All right, so you can do circles, ovoids, lines. This is called a polyline, which is just a series of lines. This is a polygon. You can make any kind of shape with sides and points. And also a path, which is just a line that curves and can go any which direction you want. And together, these allow you to do some really cool things. And when you're experimenting with these technologies at first, I highly recommend, just creating really simple demos and starting to prototype. So in this example, I have this polygon, and I've set up some sliders so that I can change the number of sides this polygon has. I can change the minimum radius. I can change the update interval for that little animation. And sometimes this allows you to not only learn more about what this element actually does, this polygon element, but also get some ideas for data visualization that otherwise might never come to you. For little animations that you can include in your site in some way. It really helps you expand the possibilities, open up your imagination. And even changing the sides back and forth. That can create some pretty cool stuff. And I'm not going to go through the full example here. You can check that out. Again, you can click on it, and it'll open in CodePen. And you can play around with it. This, again, is built with Vue. And then also using GSAP for state transitions. I highly recommend using GSAP. You can use it within any framework for managing any kind of state transitions. It's really performant, works really well, has a lot of great utilities. And if you check out Vue's state transition docs, we actually have a lot of examples of how to use GSAP with lots of different state transitions, including like transitioning one color to another color smoothly so that it sort of like blends into the next color instead of just changing, and all sorts of cool stuff. Sometimes you can do this stuff in CSS, and sometimes it's a little bit more convenient to have full control to handle this alongside a bunch of other transitions that can't be managed with CSS within JavaScript. When you're building data visualizations, it's also helpful to do some actual math sometimes. Who remembers the like high school math they did with like some trigonometry maybe, and they had like, there was X's and Y's. They remember that, but not much else. And then there was like a graph, and they had a graphing calculator that they weren't exactly sure how to use. How many people had that experience? And they thought like, oh, like I'll never use this stuff. Like obviously I'm never going to do this again. So data visualization is where you can actually do this stuff. This is one piece of code from that visualization we just saw with the polygon in order to calculate the actual, like where the actual points should be in the SVG grid. Given the value, the distance from the center of the polygon, the index of this point, is it the first point, the first like vertex, the second one, the third one, however many there happen to be, and the total number of points in the polygon. And from that, it can calculate the position of every single point. And you can see we're using like pi and cosine and sine. And fortunately, you don't have to remember how to do all of this stuff in order to build really nice visualizations. Instead, what you can do is just remember some of the basic vocabulary. Maybe like go back to that book if you still have it, or just look at like a glossary of like trigonometry terms and calculus terms to give you some of the vocabulary to ask the right questions, like how do I calculate a hypotenuse? And knowing like what a hypotenuse is, if you just know that, you don't need to remember the exact formula. You can Google that really, really quickly. Now, SVG, unfortunately, is slow. With the data visualization we just had a single element that was updating. Oftentimes, you have a lot of elements that are updating, sometimes very, very frequently. And we have a demo that is not working. Okay, here we go. So, does anyone know what visualization this is? Conway's Game of Life, yeah. Cool. So this is a simulation of how like some kind of life could live. And every second, or actually 57 times per second, we're almost at 60 frames per second, we are recalculating the whole grid based on like what's next to each cell. If there's too much crowding, a cell dies. If there's not enough resources nearby, a cell also dies. If there's like just the right amount, a new cell is born, and you get lots of really cool patterns. And right now we're getting really good performance on this. This is an SVG visualization of Conway's Game of Life. Let's turn it up a little bit though. Okay, we're at 10,000 now, and we're getting like 19 frames per second, 26. It's okay. Let's turn them up a little bit more. A little bit more, 14. Ooh, now we're getting a little bit slower. It's still not that bad, but also, if this is something that you're shipping to your users, they're probably not all on like one of the latest MacBook Pros. That's not something you can count on. So on my computer, it's working out pretty well, but on their computers, it might not. So it's good to optimize so that even on a fast computer, it's running really fast. And then in the slow computers, it'll still run pretty fast. So we're getting a little bit slower with SVG. And before I go into how we might make this more performant, I want to talk about first how I've made this SVG as performant as it already is. So these are, again, are tips that you can use in any given framework. It doesn't have to be in Vue. First, when you're iterating over a bunch of elements and they're going to be added and removed constantly, very, very frequently, instead of actually adding and removing them from the DOM, I recommend using something like Vue's vshow, which just toggles display none. So it's not being removed from the DOM, you're just changing whether it's displayed, which is a much, much cheaper operation. We wouldn't see anywhere near 60 frames per second, even with the original grid, if I were actually adding and removing those cells all the time. I also like to cache derived values with computed properties. In this case, we don't have a whole lot of calculations that we need to make, and grid width times grid height isn't particularly expensive. But Vue gives you computed properties so that you can easily cache all of those, and only if grid width or grid height changes will total cells actually reevaluate. Otherwise, it'll just return the cached version. When you have a situation when you have an infinite loop, you are constantly recalculating like the grid, I also recommend cleaning up after yourself so that these infinite loops do not become memory leaks. So here, before this component is destroyed, I set this evolve method to just a no-op, just like an empty function, so that it stops calling itself through request animation frame, which is my next tip. I strongly recommend using request animation frame instead of an infinite recursive function or set interval. With an infinite recursive function, you're going to be often like calculating faster than you can actually show on the screen. And so you might get times when it's suddenly like jumping. And with set interval, you're basically like controlling up front what the frames per second is going to be. Whereas with request animation frame, it'll go as fast as it possibly can. Now, Canvas and WebGL, fortunately, are faster than SVG. Here's that same amount of cells with Canvas, but we're actually really steady at 60 frames per second. Let's take that a little bit higher, and a little bit higher. 32,000, still getting 60, a little bit higher. 129,000. Okay, now we're getting down to 25 frames per second, which is still pretty good for 129,600 constantly changing elements on the screen. And WebGL offers similar performance. Unfortunately, Canvas is not XML-based. So we do have a Canvas element here. But from there, we have to go into JavaScript, get that element, get the 2D context from the Canvas element, then use that context to choose a fill style, which is 777. That's our background. And then fill rect. And we have our X, our Y, our width, our height. So instead of having a nice like declarative API within HTML, we have to move into an imperative API in JavaScript, where we have a list of instructions instead of just being able to say, this is what it should look like. Now, some extra tips for performant Canvas. First, I recommend minimizing operations whenever you can. So here, whenever the grid changes, I'm clearing the rect. So just like wiping the entire slate clean, rather than checking to see if a cell should be alive there, and if it's alive, then I render it, and if it's not alive, then I render a transparent one. I just clear everything, and then optimize wherever you can. So I'm using for loops here, which happen to be faster than for each or map, which usually doesn't matter in most application code. But in cases like this, where you need to eke out the most performance possible, that's where it can matter a little bit more. So here I'm using for loops to go over the grid, check to see if a cell should be there, and if it is, I draw that cell. Using fill rect, which we just saw, to draw that little square. And all together, how this is working is I render my canvas. And then as soon as this component is mounted, if you were working in React, this would be component did mount. In Angular, I forget, is this like ng init or something like that? There's another one. I'm not the expert on this, so you can ask some Angular folks later. But there is something similar in Angular. We get the 2D context, we set the fill style, and then we go through and evolve. And each time we evolve, we change the grid. And whenever the grid changes, we redraw everything. And there are other ways that you could optimize this, but this already is pretty fast. Now, what about WebGL? What if we wanted to make that same gray square with WebGL? We first define a vertex shader and a fragment shader and a canvas, and then we have all this code to make a gray rectangle. Now, I know you're probably thinking, like, this seems pretty complicated, and I want you to know it's not always this complicated. It's usually much, much more complicated because we're just drawing a gray rectangle. So this is a huge pain in the butt. And actually, when you're working with shaders, like, they are basically undebuggable. Like, if you do something wrong, it'll just fail and you won't get an error. So, well, what if you want to like console.log or, add a debugger or something like that? Nope, none of that works. You can't see anything. You can't inspect anything. You just have to write perfect code, like in a void, like those, I guess this is the one time where I think like whiteboarding a problem would actually make sense in an interview, because that's basically what you're doing here. Like you're whiteboarding your shaders, and then you'll find out at the end if they worked. So that's very frustrating. And because of that, I'd avoid writing raw WebGL whenever you can, unless you're a masochist. And instead, you can use libraries like Three.js, A-Frame, Mapbox.gl. All of these offer better APIs on top of WebGL. Three.js allows you to make really nice like 3D visualizations. A-Frame also does 3D. It actually is built on top of Three.js. And Mapbox.gl allows you to make like really nice maps, similar to Google Maps and similar products like that, which I really love. Divya, who was talking yesterday, like the first time we met, we just like geeked out for a couple hours about Mapbox.gl. But why use WebGL over Canvas? Like Canvas seemed a lot simpler. Like what use cases are there for WebGL? Well, in some cases, since WebGL is lower level, you can eke out some better performance when that's really, really critical. But also, you can render stuff in 3D. Wow! This is the slide I spent too much time on. Yeah. So the code for that is actually quite simple. That was using A-Frame. And here's another example of A-Frame with our gray rectangle that we've kept seeing. We define a scene. We add a plane, which is this little rectangle here. And then we add a camera so that we know how we should be looking at this scene. And you can even like move around and check out this rectangle. You could build like a whole world. I thought about doing that, but then I wisely decided not to. No time. And then we'll see how this loads. Are the internet gods being kind to me today? It's not downloading dependencies locally. It's for they're doing that on the server side. So this shouldn't be too bad. What I want to show you is a much cooler like A-frame visualizations that I made for Vue.js London recently, using the Vue.js London logo, just to give you another idea of what you could do with it. So here's kind of like a stylized Vue logo. And to turn it into the Vue.js London logo, let's animate it. So what I did is I drew a bunch of little pyramids. And then animated them. Just a lot of fun. And if you look closely, I added like a little bit of an offset, so it has this like cool feel. I suggested we maybe like should build this in real life and like put it in front of the conference venue. That would have been cool. The organizer wasn't into it though. And there's also things like dynamic lighting in here. You can see as they change, the lighting is affecting each side. That's a lot of fun. And it didn't take me that long. I'm actually not that experienced with A-frame yet. So some general tips in review. First of all, I want everyone to keep in mind that dev is slower. If you are working on a visualization and you notice like it's a little bit slow, and I'm working in development here now, in case I needed to change something and fix it. You might think you have a problem, but then when you actually like publish this for production, it runs as fast as you want. So before you go too far into optimizing, I would make sure that it is actually a problem in production. And the reason all of our frameworks are slower in development is because we do nice things like give you warnings when you do something wrong. And like giving you a warning requires like checking to see if you did something wrong, and checking to see if you did something wrong like is computationally expensive. And different frameworks will have different speed differences between dev and production. But remember, always before you like spend a whole week trying to optimize something, make sure you actually have a problem, build it for production, see how it works there. Now optimize repeated operations. I talked about this a little bit earlier, but some additional tips that you can use is in Vue, you can use functional components when you need to render the same component over and over again. In React, you can also use functional components or pure components. In Angular, I know there are other similar things that you can use as well, although I'm not as familiar with them. And you can also use vShow. Remember, that was to toggle display none instead of adding and removing. Like that's so important. Like that one tip often can help people like bypass a lot of like much more frustrating work that they might otherwise do. I also recommend componentizing imperative code. In Vue, you can use a feature called provide inject for this. Unfortunately, I don't have time to go into provide inject. It's kind of its own talk. But here's a link to Vue's docs. Within React, you also have the context API. And within Angular, I believe you'd solve the same problem with dependency injection. Yeah, so you can take, the advantage is that it allows you to take this imperative code and break it down into little modules that allow you to consume it in a declarative way with elements that have attributes and work much more like you'd expect them to. So that way the people who are like building the visualizations don't have to be like the same people who are using the visualizations. And the people who are using the visualizations don't have to like know all about the visualization. You can hide the implementation details. Some libraries that I mentioned, GSAP for animation, definitely check it out. All of these underlines in the slides are links. A-frame for 3D, it's so much fun. And something I didn't talk much about is D3 for math utilities. So D3 also has its own rendering model. which I do not like to use because it's often not very intuitive to people. Instead, I like to use view for rendering and view for data. And then I can use like D3 max, D3 scale linear, domain, range to draw these nice real-time updating like leaderboard bars where I can define, we start at 100 pixels and we extend all the way to 300 pixels for all of these scores. And it automatically creates that scale for us, so I get a nice get bar width function without having to do the really complicated math to make that work. And you can choose to scale it linearly or like logarithmically, however you'd want. And D3's docs have a lot of information on the different kinds of scaling and other utilities that you can do. It also allows you to do nice like color interpolation and things like that. And that's it. So this is mostly all Vue with a little D3 sprinkled in for its utilities. And fortunately, in the latest version of D3, it's quite modular, so you can pull in these utilities without pulling in the other parts of D3. And I also recommend just having fun. Like if you're not having fun with these visualizations, they're not going to be good. You have to add something special that makes you want to play with it. And the trick is just, make you want to play with it, but not make you want to just refresh and play with it all day. So I had a little bit of a problem with that polygon visualization that I made, where as soon as I built it, I built it in the morning, but that was still like the rest of my day, just like playing with that and, seeing like all the things I could do with it and, changing the way that the animation worked and doing all sorts of cool stuff. So this does require a little bit of self-discipline if you have too much fun. But also, I've had clients who, feel like they're worried that, we're not gonna ship on time, even though we're completely on schedule. And if we look at, the Trello board or whatever it happens to be, we're achieving exactly what we should be achieving at this time. But what they say, or what they mean when they say, I worry we're not going to ship on time, is it's not pretty enough. That's what they mean. They don't feel good about it. And so sometimes you end up, wasting a lot of development time, and meeting time, talking about people's fears that or coming up with solutions for problems that don't actually exist, because people have fears that they're not able to quite identify. So, adding these little touches that make, your product team, and make your stakeholders really proud of what you're building and make them want to show it to other people, can actually make you more productive overall. It seems like a side thing, but I've done this for so many projects and been able to be more productive because of that. Now this is the awkward part. If you like my work and stuff, I guess you can support me on Patreon or whatever at patreon.com/ChrisVFritz. I'm trying to make more and more time for my open source work, for my Vue work. I really care about education. I like doing this stuff, but most of the open source stuff isn't paid. I just do it because I really enjoy sharing what I know, talking to the community. And huge thanks to John Leiter from Vuetify, who's my Vuesionary level sponsor on Patreon. And that's it. I encourage everyone to enjoy the Vue. You can see these slides at fritz.netlify.com/slides/viz in Vue.